I am Dr. Ram Mohan Babu, Professor, Department of IT, RVR and SC College of Engineering, Guntur. In this section, I am going to discuss about Turing machines. Turing machine is a very powerful machine that could simulate any modern day computer. Why we have to design such a machines? If a problem cannot be solved even using a Turing machine, then it implies that the problem is undecidable. That means the undecidable problems are not accepted by our Turing machines. A Turing machine consists of a finite control. It has a finite number of states. It has a finite number of input symbols. Those are in the tape. The tape is divided into number of cells. Each cell can hold an input symbol. The tape is extended infinitely, and other than input symbols, all the tape symbols are with blank symbols, where B is the blank symbol. Tape is a memory. It is a tape head. Finite control is just like our CPU. A Turing machine is defined as M is equal to capital Q sigma capital rho delta Q naught B F, where capital Q is set of states, sigma is set of input symbols, capital rho is set of tape symbols, that is sigma is the subset of capital rho, delta is the transition function, Q naught is the initial state where B is the blank symbol and F is set of final states. The transition function in one move is denoted with this symbol. It is defined as follows: delta of Q comma X is equal to P comma Y comma D, where Q is the current state, X is the current tape symbol pointed by tape head. State changes from Q to P. After the one move, X is replaced with Y. If D is equal to L, the tape head moves left by one position. Alternatively, if D is equal to R, the tape head moves right by one position. In the transition function, will show like this: X is replaced with Y and direction. The instantaneous description of a Turing machine: x1, x2, xi minus 1, q, xi plus 1 and so on xn means q is the current state, tape head is pointing to x, y, xi, x1, x2 and so on xn are the current tape symbols. Delta of q comma xi is equal to p comma y comma r is same as x1, x2 and so on xi minus 1, q, xi plus 1 and so on xn is defined as x1, x2 and so on xi minus 1, y, p, xi plus 1 and so on xn. And delta of q comma xi is equal to p comma y comma l is same as x1, x2 and so on xi minus 1, q, xi minus xi plus 1 and so on xn is defined as x1, x2 and so on, p, xi minus 1, y, xi plus 1 and so on xn. In the first ID, xi is replaced with y and tape head is moved right. In the second definition, xi is replaced with y and tape is moved to left. Is a string W accepted by a Turing machine? Initial condition: the whole input string W is presented in Turing machine, preceded and followed by infinite blank symbols. final acceptance. Accept W if Turing machine enters final state and it halts. If Turing machine halts and not final state, then it is rejected. Consider this example. Let L is equal to 0 power n. Let L is equal to 0 power n, 1 power n such that n is greater than or equal to 1. Let n is equal to 3, then a string W is equal to 000 is placed in the input tape as follows. Initially, the machine is at Q0. If it is Q0, it encounters it 0. 0 is replaced with X, and the machine state changes to Q0 to Q1. When it is in Q1, if it encounters 0, the 0 is replaced with 0, and the machine moves right hand side. Whenever it encounters 1, 1 is replaced with Y, and Q1 state changes to Q2, and it moves left hand side. When it is in Q2, when it encounters 0, it moves on left hand side until it reaches X. When it is in Q2, it encounters X, then X is replaced with X, and the machine state changes to Q0, so that it is repeated until all the input symbols are completed. This is the transition diagram. So that when it is in initial state Q0, X is replaced, 0 is replaced with X, and machine head is moved to right hand side, and Q0 changes to Q1. When it is in Q1, when it encounters 0, 0 is replaced with 0, and the machine head moves to right hand side. When it is in Q1, it encounters Y, Y is replaced with Y, and it moves to right hand side. When it is in Q1, it encounters 1, 1 is replaced with Y, and machine head is moved to left direction, and Q1 changes to Q2. When it is in Q2, Y is replaced with Y, and it moves to left, or 0 is replaced with 0, and it moves to L. When it is in Q2, when it encounters X, X is replaced with X, and the machine head is moved to right hand side, and the Q2 changes to Q0. When it is in Q0, if it encounters Y, Y is replaced with Y, and the tape head is moved to right direction. So that it encounters Y, Y is replaced with Y, and when it in Q3, B is replaced with B, and the tape head is moved to right direction, and Q3 is changes to Q4. Here Q4 is the accepting state or final states. The representation of the state diagram is as shown. Thank you.